you for your kind introduction. This is a joint work with Florian Plötzky, Jan Pöckelbauer, and Wolf Thilo Balke. And let us directly step into the question, why should you care about narrative information access? So if you think about a line of arguments which you like, well, where you want to search for on the internet or in a digital library, then it's sometimes challenging to find the right keywords for it, right? So we have the complex line of arguments. A drug should be used to treat a disease and should be given a specific dosage form, for example, or some entities should participate with each other. It's hard to break it down to keywords, right? And so the first point is keyword-based retrieval has limitations. And for example, it is challenging to specify the interaction between the different actors. On the other hand, if we have a large corpora of publication, for example, and if we want to generate structured overviews, which methods have been investigated before, which data sets have also been used for this task, to generate such overviews over the literature is challenging. And that's why we assume it would be beneficial to formulate your information need as a query graph. So as a pattern to say, we are looking for this data set, this should be used in the method, and this method should be applied with deep learning or something like that. This is the first motivation. And our ultimate goal is something like this. A user can state his information need as a single query, and then a query processing system tries to find evidence for every claim in different knowledge repositories. So one statement might be found in a publication, one statement might be found in a knowledge graph, and one statement might be bound against a data set. So to combine different information from different places to give one answer to the query. But how does it work and what is so challenging about it? So let me first introduce you the basic concepts. So a narrative pattern is just a directed edge-labeled graph pattern. We have entity types. In this example, a biomedical example, we have the nodes with the type patient, disease, vaccine, for example, and the patient is vaccinated with a vaccine. He suffers from some disease, and the disease is an observed condition for vaccine. So just a labeled graph pattern, right? The next term is then an instance. An instance of a narrative pattern replaces the different nodes, the different placeholders, by real-world actors. So for example, Miss Smith suffered from CVST, and she was vaccinated with CAT-OX. This is a technical term for AstraZeneca vaccine. Yeah? So both concepts together. We have the patterns, basic backbones of a story fragment, how entities can interact with each other, and instances, real-world instances where real persons, real entities interact and fulfill some role, for example. And that's why we argue a narrative pattern is just a backbone, and it can be substituted by so-called narrative bindings against real-world data. So in this case, the patient is Mrs. Smith, who suffers from CVST. If we now use this for a query processing step, we might formulate the query. So some user formulates the query, Miss Smith was vaccinated with AstraZeneca. Which conditions can she expect in her case? And if we now assume that we have a set of knowledge bases available and we try to answer the query, then we might first verify, okay, indeed, Miss Smith was vaccinated, we know it. And yeah, for the observed conditions, what do we do now? Here we see CVST was observed in one case. It might apply to her case. Maybe pneumonia might apply. Maybe hemorrhage might apply. But what does this phrase might apply means? It's all about the context. And this is what makes narrative query processing different from graph pattern matching. So the first part of narrative query processing is the same as graph pattern matching in a knowledge base. You have your graph query, and then you search for matches. Yeah, you need to substitute variables, you need to verify that your entities are contained, and so on. So cover your query, bind all statements against the underlying data. But the second step is unique. If we think about narrative information, where actors participate in small context, a person is vaccinated, a data set is investigated with this method, this spans some context. And if we combine information, then we should check the context compatibility here. So for our example, it is important to only recommend conditions that may apply to her case, so to her age, for example. And why are contexts so essential? Let me give you a few examples. So in this case, we might have a biomedical publication, and the publication might state a sentence like, we report a case of a 62-year-old man and so on who developed CVST after being vaccinated with AstraZeneca. If we now do our NLP stuff and extract our statements like, okay, we have seen a patient who is vaccinated by AstraZeneca and the patient suffered from CVST, we lose all information about the context, about the important conditions which makes the statement valid. And if we now use the last statement in a reasoning step, this could be then a serious threat to the validity of the overall answer, because this disease was observed for a single man and may not be generalized in this way. And this is exactly what happens if we just tear these statements out of their scientific publication. And this is a big problem in science. Another also simple problem are the corresponding contexts. So if we have such a statement like, okay, patients were vaccinated with BioNTech and with AstraZeneca, and we observed CVST for both vaccinations. And we see one risk for the one and one risk for the other vaccination. If we break it down to a triple-like structure, like done in knowledge bases, we may lose the connection which statements belong together. So which risk factor belongs to which vaccination? If we now do a reasoning and ask, what is the risk factor expected for AstraZeneca? We are simply lost, right? So we have no chance afterwards to combine the information back, because in the NLP step, if we do text mining, then we have lost the connection here. This is a problem. So now you may ask, is it a domain-specific biomedical problem? In biomedicine, contexts are very vital, and it's a problem which occurs very frequently there. But it's not restricted to the biomedical domain. It applies to certain different domains also. If you have a look at Wikidata and you open the page of Barack Obama, then there's a statement, the statement that Barack Obama is born in Kenya. It's stated in Wikidata. If we asked for presidents of the United States who were not born in America, this could be a problem to the reasoning step. Wikidata marks the statement with a small qualifier, so stated in a conspiracy theory. So the context is somehow kept there, but it is not used in a typical reasoning step there, and this is a problem. Another example is from DPpedia. There we have the information for statements. Barack Obama was the senator. He was a president also, and he has two predecessors. If we now ask who's the predecessor for the US president, we are lost again. You see the problem? Happens in DPpedia a lot of times. So big problem here. What can we do? How can we retain context in digital libraries? So on the one hand, we may improve our extraction systems. If we think about to convert publication texts into structured representations, we might enhance our retrieval step. We could extract n-ary relations. Something like patients suffer from CVST when being vaccinated with AstraZeneca. Here the age is again missing. We could include the age, but you see the problem. We need to know the context condition a priori, and then we need to train more advanced and sophisticated extraction systems, also very expensive. Another tradition well known in digital libraries are explicit context and provenance models. So methods like the prof ontology, reification, named graphs, qualifiers, and so on. The idea there is we keep the statement simple. So again, statements in a triple-like form. And then we collect provenance information about them. So state that this CVST suffering was observed in a context old man who was vaccinated by AstraZeneca. We argued to use implicit context models instead. So the idea there is within a small publication, the context is somehow stable. So if we have claims which are observed within one conclusion of one single paper, we could assume that the context is stable. And if we now do a reasoning between such or within such stable context, we can combine different statements and we can ensure that the contexts met them. But of course, these models will decrease the recall because we cannot combine texts from different statements. In this paper, we've done a large discussion on the context topic and on context compatibility. Just a short overview. We have explicit models, high quality, have an explainability, you can define rules. So very suitable for digital libraries. But you see the problem. You need to model your context conditions and you need to specify rules. And this might work for small domains, but could be a problem for large domains. Or think about defining every context condition for Wikipedia or Wikidata. Maybe nearly impossible. And for implicit context models, it's cheap and easy to retain them, just a reference to the document and restrict reasoning to document levels. And we could do compatibility by saying something like, okay, let us combine claims from papers who share some authors. Could work, but not in every case. So maybe only a moderate quality and not easy to explain if we think about textual similarity measures. What we have done for this paper is we have implemented narrative information access to pharmacy. In a joint work with the ZBMed library and the Robert Koch Institute, we have enhanced our retrieval service for long COVID questions. So you could ask which diseases are associated with long COVID, which adverse effects are observed when vaccinating a patient, and so on. So just have a look, click on the link, play around. You can evaluate graph patterns against publication levels. For now, the service uses a simple trick to restrict context to document levels, but in future we want to enhance the retrieval step in this sense that we can combine context compatible sources, like a data set which applies to a certain publication. Let me come to a conclusion. Narrative information access allows precise and structured searches in digital libraries. We can precisely formulate our information need. And it is an extension to traditional knowledge-based querying. But in this paper, we are focused on the context. They are very vital to determine a statement's validity. And if we think about combining knowledge from different sources, so coming back to our original motivation, then these contexts are essential and we must consider them. Thank you. Okay.